of people in a minute, but probably I'll explain again. So I was looking the oncogene expression in the cancers because a lot of oncogenes overexpress in cancers. But people have been targeting this oncogene expression through a lot of GQ binding drugs. What you see is that this promoter sequence has a lot of GC-rich sequence. They tend to form in vivo unusual structures, DNA structures. They form into G quadruplexes. When you add G quadruplex binding drugs, they go and bind and stabilize these structures, and in turn, you can decrease the overexpression of these proteins in the cell, oncogene expression. And people have been tried, and people send these cells into apoptosis. That's where you can try to cure the cancer. So then what I did is that in my lab, I took some of these sequences and I studied under the microscope how they form as G quadruplexes. And I have seen that most of this sequence forms strong G quadruplexes. So can I make a, how can I understand overall if there are a lot of oncogenes, other disease-causing proteins are there, how can I study the structures in relevance of that? So mainly the G quadruplexes forms 3 G repeats and connected by a loop. So I try to systematically change this loop in between these 3 G repeats, and then I came to a conclusion that its loop sequence and loop length is very much plays a very important role in the for this GQ stability. So then over the time in equilibrium at physiological conditions, I monitor these kinetics, and I got how this unfolding state to folding states, because GQ exists 2 different folding states. One is parallel, another is anti-parallel state. So I can able to come up with folded state to anti-parallel, anti-parallel to parallel, all this kinetics information data. But however, I want to do this with the drug, how these states will change with the drug. But eventually we are going to see that if one folding state affects by drug, maybe other are not. So for this one, if I add the drug, it seems like the drug is pinching the fluorescence of either Psi3 or Psi5. So maybe FRET values may not be significant when I do that thing. So when yesterday I was talking to I-Ren Lee, and he said that he has very good experience with optical tweezers. So optical tweezers, you don't look about the fluorescence, then you can add the drug, and you can see the without drug and with drug how this folding state changes. So that's what, and also another thing I'm very much interested, when unfolded state to this forms a folding state, then where is the intermediate? Like, it's not completely unwinding, because complete unwinding of G quadruplex needs a lot of strength. Probably you just have to unwind few bases. So probably there is this reaction intermediate, because the energy state is somewhere near closer to this folding path. So that's also information you can, when you use the optical tweezers for studies, you can get this reaction pathway. So basically I want to collaborate with this guy and to see that these two, one with the drug, how it affects, another with the reaction intermediate.
So actually I was working on a G quadruplex with Chang team for his rotation project. So I'm very interested in applying force to the G quadruplex, see how the equilibrium shift toward the force perturbation. That may help us to understanding the mechanism, especially when we introduce a small molecule drug, how it affects the energy landscape of the G quadruplex. That's why we want to work together to try to tackle this problem.